our body can understand force. If somebody pushes you, somebody pulls you, you can experience the force. But apart from that, we understand one more thing. Suppose if I apply some force on my hand, let us say with this pen, I am applying some force like this. So here I can feel the force. I can feel the force. If force is more, I get a different feeling. Suppose I apply 10 Newton force. I get some feeling. Now what I am going to do is I am going to apply same force 10 Newton but like this. And then the feeling is different over here. So 10 Newton like this and 10 Newton like this, I get a different feeling. Same force, different feeling. Why? Because our body understands one more thing called pressure. Now pressure depends upon two parameters. One is how much is the force and second is this area of contact, this one, area of contact. If the area of contact is small, then there is more pressure. So we have a quantity called pressure which is defined as force divided by area. Pressure is defined as force divided by area and our body can definitely feel the pressure. In some cases we purposely want more pressure. That time we reduce the area and make it very pointed. Like you would have seen a screw or a nail or a pin is very pointed. So you can take a screw, you can take a nail and hammer it in the wall or hammer it in a wooden plate. But I cannot do that with the pen. I cannot take the pen and hammer it like that. It will not go inside. This area is too big for that. Second example is knife. When you want to cut a fruit with a knife, you would take the fruit and apply force like this. Now what you will do, what I will do is I will take the same fruit, but I will try to cut with this pen like this. Same force I am applying. Will the fruit get cut? Obviously no. Same force I am applying, but this area of contact is more. And that is why it will never put sufficient pressure on the fruit to get it sliced. At the most you will apply more force and get juice out of that, but you will never be able to cut the fruit. And therefore sometimes we purposely want more pressure. But there are some places where we don't want more pressure. We try to reduce it by having more area. For example, school bag. Your school bag will have two straps going from your shoulders like this. And those straps are purposely made broader so that they put less pressure on your shoulder. Less pressure. Same bag ka weight you have to anyway carry. By making the bands broader or smaller, the total weight is not going to change. But then you will feel more comfortable because less pressure will come on your shoulder. Now you imagine that broad and soft straps are removed and you put steel wires and then you put the bag. Maybe that steel wire will not be comfortable at all. It will cut your shoulder like this. That is because it will apply too much of pressure. So we know about force. We can feel about force. We can also feel about pressure. There is pressure inside the liquid or inside the gas. It is called air pressure. Even as you go deeper into water, there will be more and more pressure acting on you. So we want to study about that. Now first is like why there would be pressure in the liquid. Iska answer is like this. You might have seen this game where a big rope is there and which is this game? Dahi Handi. So let us say all these four boys are playing Dahi Handi. Now, since they are standing ek ke upar ek, this boy at the top has to carry only his own weight. But this boy has to carry his weight plus weight of this boy standing on his head. This boy has to carry his own weight as well as weight of these two people on his head. And the boy standing at the bottom has to carry his own weight as well as weight of everybody standing on his head. So then we can make a rule out of it. You need to carry weight of each and everyone standing on your head. Does that make sense? Definitely, it does make sense. Now what will happen? Since this boy has to carry weight of so many boys standing on his head, he will feel like he is getting pressed from the top, and that is the reason why he would experience the pressure. वो दब जाएगा नीचे. And that is why there is pressure. Now when you are standing in air like that, how many people are standing on your head? Zero. But then only humans do not apply force. Air molecules also have weight. And therefore, if you stand on the ground, let us say, imagine you are standing on a ground, and on your head there are many air columns like upper, and that air column is there up to say 100 kilometers, and you are at the bottom of that dahi handi. So weight of all those air molecules on your head you need to carry all the time, and that is why you will feel as if you are getting pressed, and that is called as air pressure. So air pressure is basically due to weight of these molecules. Now it is like air is a very big sea on earth and you are at the bottom of that. So like you feel lot of pressure. But if you go and climb and go on Mount Everest, then there are less number of molecules on your head, and therefore on Mount Everest there is only about 1/3 of pressure. So pressure is less as you climb up and go at the top on the top of the mountain. Now inside water, same thing. If you go deeper and deeper into water, more and more water molecules will be there on your head, and that is why you will experience more and more pressure. So generally we can say deeper you go inside the liquid, more pressure you will feel. Now in the exam you should not write like there is pressure in the liquid because of the Dahi-Handi principle. Don't write like that. There is no commonly accepted Dahi-Handi principle as such. But why I told you is because it's very similar and easy to understand. This is precisely the reason why there is pressure in the liquid. So that was about pressure in liquid. You can drink water or cold drink with the help of a straw. And why are you able to do that is because of air pressure. Now you may feel that we put the straw inside and we suck the liquid or we pull the liquid up, but that is so very not true. The reason is that liquid or gas can never be pulled, it can only be pushed. Now which force you will be able to apply on an object depends upon the medium. For example, if you and your friend are holding a rope in your hand, one end you are holding and other end is at your friend, you can pull your friend with the rope. Can you push your friend with the rope? You won't be able to do that because rope is not capable of forwarding the pushing force. But now imagine if you are holding a rigid rod, then you will be able to pull him, push him or lift him up, or all the type of forces you will be able to apply because the rod is rigid. Now if there is no medium between the two, will you be able to apply force on your friend? Answer is yes. You do apply gravitational force and attract, or maybe both of you will hold magnets in your hand and maybe you can attract or repel. So it depends, right? Now if you have liquid or gas, you can apply pushing force but not the pulling force. For example, if I have a pipe and if I bombard water forcefully on you, you will get pressed back due to that force of water. But on the other hand, I can do the same thing with air. I can blow air on you with a great force and still you will go back. But I cannot bring a vacuum cleaner and suck all of you inside that. We cannot apply a pulling force with air or water, and therefore it's not correct to say that we pull the water and it comes to our mouth. That cannot be done. So how it works? So this is how it works. Maybe we'll try to draw a diagram and try to understand. So let us say so this is the straw with which we are drinking, and you will be here, of course. Now how to draw. So beautiful you, and you are holding the glass and you are drinking with the straw. So that is amazing kind of drawing. You can improve upon that. If you want to make a girl instead of that, then maybe you try to draw Shandy or something, up to you. Now what will happen is like this. See, this water is always acted upon by air pressure from the top all the time. So this air pressure is there all the time. Now what you do is when you want to drink, you will suck some of the air and throw it out with your nose. Then there is some partial vacuum created over here, partial vacuum in this area. And then what will happen? There is less pressure but more pressure like this. So this outside atmospheric pressure will literally push the liquid up, and then that liquid will rise up into your mouth. So what you should say is that the outside atmospheric pressure pushes the liquid in your mouth, It's not that you are pulling the liquid into your mouth. It is outside atmospheric pressure pushing it into your mouth. Now, if you take the straw and the same glass and stand on the moon and you try to drink it, you will not be able to do that, because no matter how hard you try, there is no atmosphere on the moon, so there is no pressure acting on it, and therefore the liquid will not get pressed up and it will not work. Now, this person is very horrible, so let us remove it out. And now all of you can draw the diagram and then write the proper conclusion. What you should write is, outside air pressure will push liquid up. You should not say that I am pulling the liquid up. It is outside air pressure pushing it up.
This activity. Take a bottle and make two holes to the bottle A and B as shown in the figure. Fill it up with water up to this mark and then observe how the water is coming from both the holes. What do you observe? Draw a diagram and write the conclusion. Second experiment. Take a similar plastic bottle and make 4 to 6 holes, but this time all the holes should be at one level or at same height. Again fill it up with water and observe how water is coming from all these holes. What do you observe? Draw a diagram or sketch and write your conclusion. This method is called siphon method. Water moves from higher level to the lower level. So there should be a tank or the source of water and a destination bucket. A bucket or destination must be at a lower height from that of the source. In this case, if you directly put a tube, one end inside this tank and other end in the bucket, water will not start coming on its own, because how the water will climb up and then come down. So we can use siphon method. What you have to do is fill the tube completely with water using a tap and block both the ends with your thumbs like this. Put one end of the water, put one end inside the water source and then release the thumb, and other end you have to put in the bucket like this, and you will find that water starts coming through this pipe and the tank can get empty. This method is siphon method. Try doing this if you can. You must have seen a syringe or a pitchkari. You have to put this lower end of the syringe into water and pull the piston up. Once you do that, you will find that water enters into the syringe. So why does the water enter into the syringe or pitchkari? That is first question. Next, when this is filled up with water and if you press the piston, you will find that water comes out forcefully and it can travel a large distance. So the question to you is, why does the water go to a long distance when we press the piston of the syringe? This is a spirit level. It has got a small glass tube inside filled with spirit. This is a air bubble purposely kept inside the tube. Use of the spirit level is to see if the surface below this is horizontal or not. If you keep this on a table and if you find that the bubble is between these two lines, that means your table is horizontal. Otherwise, if your table is inclined, then this bubble will go to one of the ends. This is the method to check with spirit level.